Okay, hello, welcome to my channel. My name is Solo Anch, and in this video we want to find the value of x if sine of x plus cosine of x is equals to 2. Good, so here with me is McKay, and right here is our first official video using a tablet. Alright, I hope you enjoyed the video, and if you do, please don't forget to subscribe to my channel, share with your friends, and in fact, let's continue. So I'm just happy I had this because sometimes light could be very disturbing in my own side. Okay, so you want to solve for x if this equation is true. Okay, so if you know this, you know already that this equation is not possible, that the sum of sine and cosine cannot be up to 2. You may say, well, the highest sine can be is 1, the highest cosine can be is 1, so wouldn't their sum be 2? Because 2 can be possible. But you know, cosine are not the same function. Okay, they're not equal, so their values at x, you think that the inputs are equal. So sine of an input, if sine of 90 is 1, cosine of 90 is not 1, cosine of 90 is 0, so that means the sum will still not be up to 2. But let's check if this is true all the time, if the sum will never be 2, and if it is not 2, can it be more than 2? Or maybe less? And if it is less, what is the highest if the value can be? Okay, but if you don't know maybe already that sine x plus cos x is not equal to 2 for all values, for all real values of x, maybe we can show you that a little bit. So maybe let's just look at that. So I'm not going to do a lot of work here, so we're just looking at sine x plus cosine of x equals to 2. Okay, good. So we square both sides. So when we square the left hand side, you notice that the square of this binomial will give us sine squared plus cosine sine squared of x plus cosine squared of x, okay, plus 2 times their product. But 2 times sine x cos x is the same thing as sine of 2x from some trig identities, equals to the square of the right hand side is just 4. So the sum of these two is 1 from trig identities. So 1 plus sine of 2x is 4. Sine of 2x is 4. It means that sine of 2x is 3. Good. But sine of 2x is some angle. So for example, you can call it theta. So sine of some angle gives us 3. That's absurd because again, sine of an angle cannot be more than 1. So yeah, that is where the thing breaks down. Good. So how can we do this? I wanted to show also how to do this using calculus to check the maximum value that the sine can have. So I'm going to start off by letting this be a function. So I will say let f of x, okay, be a function defined as sine of x plus the cosine of x. That's a function. So what we want to do is to look at the stationary points. Okay, so the points where we can either have a maximum or a minimum. So when we differentiate sine of x, we get cosine of x. Then we differentiate cosine, we get negative sine of x. So that gives us negative sine of x. And to get the stationary point, of course, we have to equate the derivative to 0. That is a point where the slope of the tangent line is equal to 0. But equating this to 0, this is cosine of x minus sine of x equals to 0. It means sine and cosine will be the same, all right? But which angle can sine and cosine be the same? Well, that is when the angle is pi over 4. Or let me say pi over 4 is a candidate. So if you look at the quadrant, let's say 4 quadrant, okay, on the first quadrant, sine and cosine are both positive. And when you take sine of an angle, let's say pi over 4, the value is the same thing as cosine of that angle. So that's why we are saying that the first candidate here is pi over 4. But is it the only value of x that sine and cosine can be the same? We're looking at the second quadrant. In this quadrant, it's only sine that is positive. So if it's only sine that is positive, it means that the other two basic trig functions like cosine and tangent, they are both negative here. And there is no way sine and cosine can have the same value if sine is positive and cosine is negative. So the second quadrant will not have an angle we need. Looking at the third quadrant, here is only tangent that is positive, which means sine and cosine are both negative. Yeah, it's possible to get a value that is an angle that in which sine and cosine are going to be the same. Well, it's possible, but it's not absolute. You can't really be sure, but it makes sense to investigate here instead of here. So looking at this third quadrant, since here we considered pi over 4 to be such an angle, if you add 180 degrees, that is, if you move just on a straight line like that, you will meet the angle here, which is going to be 222 degrees, which is something as pi over 4 plus pi, because you're just adding 180. And out of 360 degrees, if we add pi again, we'll get back to the way we started, which is pi over 4, and so on and so forth. So there are two from 0 to 2 pi. Okay, there are two unique angles, which is pi over 4 and pi over 4 plus pi. But pi over 4 plus pi, we can also rewrite that as 5 pi over 4. So there are two unique angles, which are 5 pi over 4 and pi over 4. Good. So we're going to check for these two, which of them will be maximum, which of them will be minimum, or maybe both of them. Okay, that is when x is 5 pi over 4 anyway. So to test for either maximum or minimum, we can use the second derivative. So we differentiate the function the second time. We differentiate cosine, we get negative sine of x. Well, then when we differentiate negative sine, we get negative cosine of x. And then maybe let's factor out the negative sign. Notice that we're going to have the same function, sine x plus cos x. But the value, it doesn't really matter here. All that we care about in this case will be the sign, whether the sign will be negative or positive for each critical point. So when x is pi over 4, put in pi over 4. Sine of pi over 4 is root 2 over 2. Cosine of pi over 4 is also root 2 over 2. Remember, they have to be the same. But root 2 over 2 plus root 2 over 2 is the same thing as root 2. Then that is negative, which means that this is less than 0 when x is pi over 4, and it is that's when x is pi over 4. But what if we substitute 5 pi over 4? Take note, sine and cosine have negative values here, and it's going to be negative root 2 over 2 for each of them. So when x is 5 pi over 4, sine of 5 pi over 4 is negative root 2 over 2. So maybe let me put it out here, negative root 2 over 2. Cosine of 5 pi over 4 is also negative root 2 over 2. So that's inside the bracket. Then we have a negative outside. So when we add these two inside the bracket, we're going to get negative root 2. Then with the negative sign outside, so this is greater than 0 when x is 5 pi over 4. What does that tell us? That tells us that 5 pi over 4 will give us a minimum point, while pi over 4 will give us a maximum point, because the second derivative is less than 0, we get maximum. When the second derivative is less than 0, we get minimum. So what does that tell us? That tells us that this function, the highest it can be is pi over sorry, it's not pi over 4. Is the value when x is pi over 4. So what would that value be? So we need to substitute the value of pi over 4 into x in the function. So when x is pi over 4, this is sine pi over 4, which we've discussed already as root 2 over 2. Cosine of pi over 4 is also root 2 over 2. Adding the two together, the maximum is square root of 2, which is close to about 1.4. It's approximately that, but the approximate value will not give us the exact. This is the exact value. Root 2 is an irrational number. Good, that's very nice, isn't it? So since this is the highest we can go, it means that the equation which we started with is not possible. Of course, we said that already. So can we get some solution, maybe even if it's not a real number? Okay, so that's what we want to check right now, if it is possible to get some other solution. Okay, so let's see what we can do. So maybe let's start off with the original stuff, which is sine of x. So let's have sine of x plus cosine of x equals to 2. Good. So here I'm going to use the complex identity for sine and cosine. So I'm not going to write them out, right? I'm just going to use them at once. So sine of x. Well, using the Euler's representation, we know that sine of an angle is e to the power of ix minus e to the power of negative ix divided by 2I. That is for the sine. Then for the cosine, it's going to be e to the power of ix plus. So the only difference is that at the top, in place of minus, for the sine, we're going to have plus for the cosine. Good. So this is divided by 2. So and another thing is the denominator will be 2. So this is the plus sign. Then this is the equality with 2. So what I'm going to do here for the representation for the cosine is I'm going to multiply numerator and denominator by I. That is to make the denominators in both fractions to be the same, so that we can easily add. Okay, so let's see what we get. So you notice the denominators are the same. We keep a single denominator and then we add the numerators. But when we add the numerators, this will leave us with 1 plus I into e to the power of ix. That is by adding this term to this term. Okay, after distributing the I. Then the next thing will be this minus sign and then this plus. We're going to have minus that will be 1 minus I, where the I is from this bit. So this is e to the power of negative ix. So you check that out. Well, on the denominator, we're going to have 4i, and then 4 is from 2i times 2. Good. Okay, so let's see what we can do. So from this equation, I'm going to multiply both sides by something. What would that be? I'm going to multiply both sides by e to the power of ix. So notice that when we multiply the left hand side, the first term in the left hand side is going to be, that will be 1 plus I. So let me write it well. 1 plus, okay, I into e to the power of ix. But it's the same thing as what we're multiplying outside, so it's going to be the square of that. Then the middle term, the e to the power of ix, will cancel out with this. So for this last term, well, let's move it to the left hand side. That will become minus 4i. We multiply it by e to the power of ix because we're multiplying both sides by the same thing. Then we'll be left with negative of 1 minus I. So this is equals to 0. That's because e to the power of negative ix times e to the power of ix will be 1. Okay, so this is a quadratic in terms of e to the power of ix. So maybe let's make that the subject using the quadratic formula. So by using the quadratic formula, this is going to be negative b, all right, where the b is negative 4i. So that will be 4i, that's negative b, plus or minus the square root of b squared. But the b squared is negative 4i. When we square that, what do we get? The square of 4 is 16, and then the square of I is negative 1. That's negative 16. Minus 4ac. But 4a, this is a, this is c. C has a negative, so that gives us with positive 4 times a. A is 1 plus I. Okay, times c. C is 1 minus I. Not just that, negative 1 minus I, but we've used up the negative already in changing the sign of negative 4ac to plus 4ac. Plus 4a, then minus c times minus c. Okay, so that is divided by 2a, but a here is 1 plus I. That is the coefficient of the squared term, and the term here is e to the power of ix, which we've made the subject. So okay, we continue up here. So this is going to be, well, let's see, inside here 1 plus I times 1 minus I. Let's expand that. 1 times 1 is 1. Okay, this is like a complex number multiplying its conjugate. The result will be a real number. I times negative I, that will be positive 1. So inside here we have 4 times 2, which is 8. Negative 16 plus 8, that's negative 8. So up there we're going to have 4i plus or minus square root of minus 8. But in fact, let's simplify that. That's a lot of simplification in one step. Oh dear. So this is 4 plus or minus, okay, let me frame that. Okay, that is supposed to be plus or minus 2 times I root 2. So why we have 2 root 2 is because square root of 8 is 2 root 2. Then the square root of 8 is going to be joined with I because square root of negative 1 is what we define I to be. Good. In the denominator, we have 2 into that. That is 2 into 1 plus I. That is just e to the power of ix, which we have on the left hand side. Okay, great. Now let's see. Well, I can factor out the 2. So notice that the 2's will cancel. So the 2 here will cancel out. This will be left with 2 because that was 4. Then the 2 on the bottom does causes all this trouble. Then okay. So let's write out what we have left. So what we have is e to the power of ix equals to, that is 2i. Okay, 2i plus or minus that is I root 2. Maybe I can just say root 2i. So maybe you can factor out the I and then see what we get from there. So this is 1 plus I. Okay, then the next thing I'd like to do would be to, like I said, factor out the I from the numerator and then take natural logarithm on both sides. Why are we taking natural logarithm? Because we want to recover the value of x. Okay, good. So let me rewrite this so that we can take natural logarithm on both sides. So I'm going to take the natural logarithm on the left hand side and then the natural logarithm on the right hand side. So we have, natural exponential function, which is the inverse is the natural logarithmic function. So yeah, that's why we're taking the natural logarithm to recover the x. So the natural logarithm of that will give us the identity, which is ix. Then the natural logarithm of the right hand side, which is this, what we have here. So maybe let me not try to help the fraction, the denominator, but rather let's use the logarithm properties to state that the logarithm of the ratio will be the difference of the logarithms. In other words, we're going to have 2 plus or minus the square root of 2 into I, like that. That'll be the natural logarithm there. Then we subtract the natural logarithm of 1 plus I. Good, that's what I meant. Good. So the next thing is to multiply both sides by negative I in order to get x to stand alone. So when we multiply left hand side by negative I, we get 1x, which is just x. We multiply the right hand side by negative I. So I'm going to bring the negative I. I'm going to write this term first, because that would make us have I into the natural logarithm of, so let me put it out there, I times the natural logarithm of 1 plus I, that is it for this term. Then over here we're going to have minus I times the natural logarithm of 2 plus or minus square root of 2. So this is not just one solution, okay, there are two solutions there, and maybe we can also split that, but I mean, let it just end here. Okay, so notice what we've done there, just by multiplying the left hand side by negative I, and then the right hand side by the same thing, negative I, and then this is a negative I, which returns this place to positive I. That's why we have I here, this one leads to that, then this one leads to this side, and that is the value of x that will make that equation possible. And of course it is complex, and I don't even know how how to even think of this value sincerely. I don't know how to think of it, but hopefully that's it. Okay, hope you enjoyed the video. Please do well to subscribe to my channel, share the video with your friends, and we'll continue from my next video.